Thanks for joining us here. Hopefully you find some of what I want to talk about useful. This a little bit of a departure from a lot of the other talks I saw today about some of the challenges we all face when it comes to purple team type situations. What I wanted to do was focus on something a little more tangible, a little more tactical, and that's why it's also in the title. Is I find myself in many situations where I want to either add some visibility. Maybe I'm working closer with the blue side of the purple team and they're dealing with some kind of an API or a business partner connection, and they don't have the visibility they think they need. Or on the attack side, maybe they need to work around some complication. And so I started looking about more than just the base case of, hey, I run a tool like the old favorite of EtterCap, I get in the middle, and then I do something evil. I wanted to really draw some attention to some of the ways you can use it creatively or similar tools. Use the concept creatively to either enhance your defenses or to better be able to work around some of those complications you may find yourself in. So I guess we'll just get started. If you are looking at a recording, these slides, I changed a couple of things in the images. So if you're looking at an old copy and you're missing some slides, just try to find me somehow on Discord or Sans, and I'll make sure you get a copy of the current version of the slides, just in case that shows up incorrectly. But as Barrett introduced me, I've been around Sans for quite a while. I still do mostly balanced purple-like day-to-day work. We work with a lot of clients from the boutique firm that we have, and it's me and just a handful of friends, and we are real picky about the projects we work on. So it works out really well to be a small organization. We get to do that. We get to come and do awesome things with Sans. I've also contributed to some other Sans courses as well, like $6.99 and $5.99 I taught for years, as well as some of the forensic stuff way back in a previous life. So that's a little bit about where I come from. I was really started off as an under-resource equipped system administrator and had to get real creative. So a lot of my stuff is hacker building, not just hacker breaking things in a background. So if I had to look at myself historically, a lot of stuff depends on what I learned as a system administrator, more so than as a developer or even as a pen tester. So it's going to be easy to see how some of the things I talk about map to an attacker. But what I'm trying to do is open up your mind how to use it a little more creatively and do better attacks, or to turn it around and use those same things as defenses. So purple, yes, maybe a little less of the team part of the track. Although there's no reason you can't do it as a team. It's just more tactical, not strategic. All right, so there's a lot of opportunities to be in the middle of stuff. Most of us, we think MiTM, we think of your ARP poisoning on Ethernet. You can't just be the IPv4 address. You have to also deal with the physical address to logical translation, right? So we have the ARP poisoning to become in the middle. And we're not going to talk much about that. But what I would like to point out is that same idea, since we have a stacked, layered network model, even beyond this model, we can still do things at other layers. I mean, even EtterCap has tons of different ways to be in the middle. Maybe tons is an exaggeration. There's a variety of different ways to be in the middle with EtterCap that isn't just ARP poisoning with IPv4 physical to logical address mapping. It'll do IPv6, it'll do DHCP spoofing, racing DNS. There's so many other things you can do. Also, what if I maybe find myself stuck in some kind of a hosted environment in the cloud? I get some kind of a foothold on something like an application server that interacts with another database server in the cloud, and I want to try to eavesdrop on that connection. It's going to be harder because most of the cloud providers don't allow tenants to be in promiscuous mode. You can imagine the chaos if that were possible, right? You could sniff and get some random third-party information going across the wire. So you can't just run those tools. So you try to solve the problem in a different layer. All right, and we'll talk about a couple, but the first one I'm going to talk about is really just moving an endpoint. So you want to be in the middle, and yes, in some ways you have to have some level of access to do what we're talking about here. It's not that we're just breaking in with these techniques, but it's more about we're struggling getting past the filter as an attacker, or as a defender, we're having a hard time blocking the attack. We might be able to move the connection somewhere that makes it easier for us to defend or attack. And as an attacker, I don't want a defender to tear down my attack either, if I'm talking for the moment about pure red and not any kind of purple or blue. I need to defend my connections against the defender, right? Killing them. So these techniques would definitely apply to that. You know, like I mentioned, maybe a cloud-hosted mode, you can't be promiscuous. Maybe there's a regulatory reason you can't see certain things. You're not allowed to. And cheating that, of course, involves lawyers, probably, to do it right. But maybe it's more of a practical thing, like this one thing is in the way, or we're doing this over a VPN connection, and we can't do the ARP poisoning because it messes up the VPN. You do a VPN in a tunnel mode, and the ARP proxy just doesn't work if you start messing around with ARP packets. So we have that. As I was saying before, though, as a defender, I might be able to take some existing connection I don't really have permission or access to manage fully, but I can be in the middle and now create some visibility so I can see what's going on. And that's really what we're doing when we have something like an HTTP proxy that does SSL inspection. We're really just taking the tool the attackers we know about use to eavesdrop on client to server communications and manipulate stuff. Well, we can do it as a defender. All right. So I'm going to zero in on one tool for the transport stuff, and then later we'll talk about a little bit more of a DLL in the middle kind of a situation to get much more, I don't know, specific. All right. So I hope you've had the pleasure of using SSH tunnels. They're amazing, no matter what you're doing. I really feel that it's one of the underplayed, valuable tools to us in InfoSec. Whether you're a defender or an attacker, SSH tunnels are amazing. You may have used some simple ones like a local, I want to listen on a port and just map it to the other side of my SSH connection. You know, that's not really all that creative by itself, but maybe you're a little less familiar with the other ones. The dynamic one basically is creating more like a SOX style proxy, where dynamically any connections coming in one side, the client side, will come out dynamically the other side. Very nice for you're in something like a conference and you don't really trust the wireless, or whatever the wireless is plugged into, you may not trust. You can SSH to tunnel to somewhere you trust, and all of your browser traffic, if it's pointing to that SOX tunnel, dynamic SSH tunnel, traffic just comes out the other side after it's all been encrypted along the way. Really, really powerful. But the one I'll look a little bit more in detail is the reverse. It's easy to get confused, and I hope, actually, one of the reasons the slides are different is I had some images in there, thought it was too confusing, deleted them, submitted the slides, and then I thought, you know what, I kind of need those back in there. So hopefully the images don't get too confusing. But conceptually, I want to explain, we have access of some kind. We have an SSH account. The green here on the slide, on the right, the SSH server, may be something we've broken into, or maybe it's just something we have access to. Whether we're a defender, an attacker, let's just talk about the mechanics of the tunnel first. I'm connecting from the middle box, I'm running the SSH command on the middle box, to the SSH server, it's on the right. And then the idea is I can bring whatever port service is on this right-hand server, I can expose it to some other IP address and make it look like it's a service on another machine. So this is great with honeypots. This is great with, well, lots of things. It's great for testing. And I've even done this with the SSH service itself to bring SSH out. If I had a foothold in, like maybe I'm doing command injection, remote code execution on a web app, but I don't have a great connection, I might start an SSH client on that server with the command injection that brings SSH out of the environment where I can get to it better. So this host on the, haven't talked about yet on the left, could be anything. As long as the client machine can reach it, it's going to be able to do that. The weird thing about it is the direction, I think, that confuses people. When they do a reverse tunnel, they confuse about which direction. And you can start to look at the command and break it down, some gotchas, I guess. Here, I've tried to specify the SSH server. This is not necessarily the target server I'm trying to defend or attack, but this is just what's hosting it. And so you see at the bottom, I've got some example commands. And then we have the new host, or this new port on the new host. That's what I want to actually bring through the tunnel. And I can do a combination of local and reverses if I want to change the direction too. So it can get quite ugly, but I don't know why I'm so excited about it and other people aren't, because I've done some really bizarre things that people are like, wait, how did you do that? And it's taken a long time to try to work through it. So let's break it down into smaller, maybe more familiar ideas. Your classic netcat with an standard input output, but mapped to an executable. We can -E, and then we can execute a shell, but we can also have the opportunity to obfuscate, or the opportunity to filter. So here's an example of the defender would using it for filter. Just maybe they, I don't know why we're replacing Mimi cats with, oh, MiTM cats. I glanced at that and didn't even read my own writing, typing anyway. I was like, why are we replacing it with the same word? No, there's an extra T in the second clause there. But why would I want to do that particularly? Well, I'm introducing typos, or I don't know. That's probably a horrible example, but I can change text. I can neuter text. I can break things. Someone's trying to run some evil command. I can make the command not evil. I can make it not even work if it's passed through, right? So I could do that. If we want to do the equivalent with SSH, pro tip, -T is awesome because it fakes a terminal, a TTY, and so it's a lot easier to handle automation and standard input-output redirection. So I always add a -T to my SSH when I'm doing creative stuff. So with that, I'm connecting to the machine. Again, I'm not breaking in. I have access to that machine somehow. If you can set it up ahead of time, of course, your SSH keys are going to make this easier to automate instead of just doing it by hand and getting password prompts. But here what I'm doing is maybe I wanted to do this similar type sed command because, I don't know, maybe it's obfuscation, though, as the attacker. I'm trying to use a different thing than the signature the defender's looking for. That would be the kind of thing I would do for it. But that's just some pieces. What I want to point out is the SSH tunnel itself we're introducing a layer of abstraction in between TCP transport and the local networking, the network layer. We're adding a layer in between those. And so we have an SSH command for adding the layer, creating the tunnel, and then we have one that actually does the connection inside of it, which is why we have SSH doing a reverse port, anything that passes through the sed command, we can replace anything with another thing and end up somewhere else. So you can start to look at this, like, the quoting is important to note, but hopefully this triggers a little, imagination, I guess, is really what my goal is. Would I type exactly this? Probably not, but it'd be pretty close. It depends on what I'm trying to accomplish. All right, so, our classic concept of being in the middle on a network to redirect traffic to some other host, it usually is easiest, to be honest. It's still the most common way to do your classic ARP poisoning because IPv4 is everywhere. Even if you have switch port security, learning about physical addresses on each port and not allowing a lot of moving around, there's going to be exceptions. There's going to be multicast addresses. There's going to be other ways for it to work. But yeah, I still would try IPv4 ARP classic stuff first. It's the easiest one to communicate. But don't forget about your IPv6 options. IPv6, even internally, may not be designed to be used, but it's enabled by default on pretty much everything. And it has some auto configuration properties in most default configurations where you can do the same thing as ARP poisoning. A common misconception, we have IPv6, so you can't ARP poison. We can check that off of our list. We now mitigate that, but it's not called ARP poison. It's just poison when it's IPv6. We can do a neighbor discovery. It's ARP, but for IPv6. There's even the router advertisements we can do for the gateways. And we can still be in the middle. That brings me to the idea of alternative LAN man in the middle. Maybe I don't want to be a meddler between 2 points on the same local network. If I wanted to be something that leaves the network, I have a different set of options. And I alluded to it before, but something like EtherCap has a DHCP, malicious DHCP option. We can just have a rogue DHCP server that's not a specific attack tool, just use it maliciously. And yes, there are mitigations that might deal with that, but you have to ask yourself, how do those things work? Like your Cisco switches, for example, and others, that try to detect DHCP servers that aren't officially blessed by the network. Well, we can still do our IPv4 ARP poisoning to be in the middle of the multicast address. We can still race the DHCP broadcast. I mean, how does it even hand out IP addresses? If you think about it, it doesn't have an IPv4 address really assigned to it yet. It has to get one, even though it borrows one from this DHCP mechanism. Point being, we can say, I'll be your gateway and anything leaving the network. I don't prefer that personally because I find it's not as surgical precision. But if you're using a tool like BetterCap, it loves to be the gateway for everything, almost to a fault, I would argue. I still prefer EtherCap surgical precision personally. So you have that option. But what about those other layers? So those are the two most people lean on. As I said, that yeah, maybe if my goal is to really monitor a service I don't have access to. Maybe a vendor supplies an appliance on your network and you're still kind of responsible around it, but you don't have administrative access to that box and you need to defend it. Or you're trying to find out why your attack's not working. Maybe you can work around those kinds of problems. So it's not just the protocol stack layers from 1 to 8, but it's about what happens before that happens. So of course, DNS happens before that happens. I already mentioned DHCP happens before that happens. So we can ARP poison the DHCP servers. We can work it in an order of precedence, not on the actual stack. And that's getting to be pretty complicated, surprisingly. This may not be news to you, but if you stopped and looked at this, I've had to go through and troubleshoot some things recently. That was even, it was a nightmare, but it had to do with, on some Linux machines, how they use systemd resolve D to do the DNS lookups. And we're dealing with Wise Firefox on the Linux desktops, acting differently. Was it an attack? Was it just breakage? And it was trying to help somebody solve their problem with some fancy enterprise security product. It turned out to be they didn't understand what Linux was doing. But that is something that exposes an opportunity that maybe you don't realize with the proliferation of DNS over HTTPS. I mean, wow, how does that get handled? It might be another opportunity to intercept. From the defensive side, are you logging that? How are you logging that? And then when you're trying to do DNS lookups for your own log parsing, are you able to see that in the same place as your regular DNS stuff that might be coming over UDP 53 or whatever? All right. So consider some of those. And it makes sense to think about it in some behavior. So yeah, I mean, we can talk HTTP and hijack that, but I like to look at the email too, because like Dave Kennedy said in the keynote and other people, a lot of it's about the story, the context, because while we can have technical controls that help mitigate, it still depends on the workflow of what people do. So let's just take a quick peek at email, just to look at it. If we wanted to deliver phishing or want to deliver something malicious, or wanted to know as a defender, are we able to see these things malicious? Where are opportunities? You know, if it is truly a malicious person, we may not, if they're not an insider, have visibility to their endpoint. They're creating this phishing email. We have no idea how they're weaponizing that until we see it, right? But beyond that point, if we're lucky, we might have visibility on their SMTP server. But again, if it's not an insider, probably not. That's pretty extreme. More realistically, when their DNS server goes across the internet and asks our DNS servers, what's your MX record? What's your SPF? What's DMARC and all these other settings? That's the first opportunity we have to see it. So now we can look and see, is perhaps the behavior coming in hijacked or not? We can't make the decision yet, but we could at least record it for reference as like a starting point of when the attack started. If we had it logged, we can refer back to it. All right, so at that point, of course, if I wanted to hijack existing email maliciously, I've got all these different arrows where I could place myself and change it. I don't have to literally be in the middle. That's why there's a big red X. I could just redirect it to somewhere else. I mean, whether it's a DNS registration attack, again, not in the protocol stack precedence, but in the this happens before that concept, I could do it there. We're trying to think outside the box and get closer as we get in. What about, I as a defender can see that lookup and replace it, do a little bit of a switch. Example, what an attacker would do, something like this, yeah, and redirect to a more rogue domain controller that would serve up an incorrect mail server, so the email's routed through them before it comes to the actual destination. But a defender could also do this to hijack their own inbound traffic and send it to a sandbox, send it to something that can log. There's a lot of opportunity for that. All right, so we're not going to get too much detail, but there's always a consideration, is my point. There's lots of options. If you can't do it because of a regulatory reason or equipment or permissions, different organization is in charge of that, there's going to be another opportunity somewhere. All right. And, to get, again, in a little more modern aspect to that, a little more specific, I mentioned dealing with the issue where Firefox on Linux, the DNS over HTTPS is automatically enabled, but by region now. So in the US, it defaulted in early 2020, but it does have some sanity checks. If it can't resolve a revocation list server, if it can't resolve its, I think it's using Cloudflare DNS over HTTP servers. If it can't get there, it regrets back to whatever's built in the system. But then the system can also have its own. I already gave away that it was systemd configuration. That was the problem there. It depends on your distribution, of course, but on Linux, it has different ones. I have Windows first, Linux the next slide. But here we're looking at Windows name resolution. This is a favorite of mine to pick on because Microsoft's documentation is contradictory on the Windows side. But if we're looking at the vintage of Windows 7 and later, for workstations, if there's not been a lot of creative things, like it's been upgraded since XP, all the way to Windows 7, this is again, the order of that progression. It's going to check to see if it's configured host name. If it's not, it checks its DNS cache. Some documentation says it also checks NetBIOS at this stage, but based on using a Windows debugger to watch this, that's not what I saw. I believe it if somebody said under certain conditions it did, but apparently it doesn't, at least not what I saw. Again, I was looking at Server 2008 and Windows 7 when I did most of this research. When I popped into Windows 10, I didn't see anything different. I didn't look real hard, to be honest, because it all looked the same. So just your mileage may vary on that. Of course, if it hasn't really been loaded, because it actually does load in those host files into the cache when the DNS resolver service starts. So some documentation says it checks the file. Well, not really. It's already loaded the file. Then it will do a normal DNS, right? Checks your first DNS server, asks it, asks the next one, et cetera. And of course, if I was an attacker, I could denial of service those and try to get to a point where I could maybe hijack the DNS with the ARP poisoning, as I mentioned, or race the answer, spoof the answer. Then the code does fork a little bit in watching it with Windows Debugger. If it's not a fully qualified domain, like there's no periods in it, it's just a single host name, it will try LLMNR, the link local multicast name resolution. And again, that's a lot like ARP in that anybody locally can answer it and say that machine you're looking for is over here. Another perfect opportunity to be in the middle, which we love to use with responders. Great at that. And then if it's less than 16 bytes of a host name, it actually does some NetBIOS stuff, even if you've disabled NetBIOS broadcast. Yes, it still does it. It may not do the actual broadcast, but it does go, the code does go through the cache, which I find real fascinating because you can do a NetBIOS, you can do some things locally to poison the name cache, even if NetBIOS broadcasts are disabled. Now, so it's kind of funny to look at that. Are you going to use that for every engagement and project? Well, no. My point is to stop and think about and do a little research about how these things progress. And then be prepared to look it up again because the documentation's wrong. All right. Finally, again, the LM host is the last thing that gets checked if it's less than 16 bytes. So I don't know, I always find that fascinating to go through there and find those little edge cases of when I might be able to manipulate something. And you stop to consider this, especially since the host name length is interesting to me, because I can make DNS records that point to a short host name with a CNAME record. And then how does that play into it? You know, a good question. Does it get cached? If I had a DNS CNAME record that points to a 16-byte host name, the DNS cache would save whatever that lookup was, which might actually point it really to something they got from NetBIOS under special conditions. I don't know, pretty fun stuff to me. Maybe I'm weird, but we also have on Linux and Unix style, we have this nsswitch.conf file that has the order of that DNS resolutions. Pretty typical pre-Ubuntu 20 and BSD is pretty common. Files, resolve, and then DNS. So pretty common, but if you have some enterprise stuff, you might likely have that in play as well. The caching isn't really there unless you have the NSCD service running, not pretty common. But basically, if you look at a modern Linux, I'm not talking about dark ages, it's going to look for the order resolution with the nsswitch.conf, then it's going to decide if it can answer with synthetic file configuration first, it will. You know, not just is it localhost or local domain, but is it something .local domain? It's going to try that first, then it will look in the host file. Like it literally just assumes you left off the .local domain if you just gave it a single host name. So if you're trying to do your engagement, you're trying to be in the middle of DNS names, you've got some filtering on DNS names, but the fully qualified canonical DNS name isn't being used, it's not going to be match or filter. It's going to get answered and it's not going to show up in your logs. All right. And then there's some other exceptions for multicast, of course. So pretty interesting to me, especially that reverse lookups. If it's .local, anything .local will never get used. So that's like, okay, great. All of my domains then, especially if I'm dealing with an organization that's a sub of another organization, and I can get a .local somewhat closer to the target, that's going to be a great one to do, because now there's a lot less complexity. The reverse lookups are the IP address to host name, not the host named IP address, right? So some fascinating stuff to me, and it really depends on what you need. So again, the point was to kind of look at that and say, you know, is there anything here I can take advantage of? Not just pure red team to attack, but can I have an opportunity to increase my visibility as a defender, is what we usually look at with that. Okay. So we looked at some things there, but outside the box, even literally, what could I do? Something like I mentioned with the gateways is a little more along those realms of dealing with something before all those things happen. But, you know, both the server and the client have to boot, physical attacks. I mean, what other kinds of things if we want to think about a specific thing we can't monitor correctly or attack the way we'd like, how can we better do those things? And so something that experimented with quite a bit was some malicious network booting. And we used to do this in 660. I took it out because it's just harder to do this in a classroom, especially a virtual classroom where people are coming in on VPNs and stuff. Because it's just, you have UEFI and other people try to do it from their corporate laptops that have secure boot enabled. And it's just a lot of work to try to demonstrate it. So we don't really do it as an exercise, but the concept I want to draw attention to, especially if your challenge is something like, I'd like to do a physical attack, but the device is remote. Well, if I could maybe bring the device to me, it can be attacked differently. Malicious removal media, for example, like a virtual USB drive, can be done quite easily in virtualization security. So I used VMware's virtual infrastructure, took an ESXi hypervisor, threw out a bunch of stuff I didn't need, but in the end, we ended up with taking something like at the time it was Windows XP as a victim on a machine, booting on its hard drive, but getting VMware underneath it maliciously as the attacker and bringing it to us so that we could do things with it. And we did it, the technology that we used was actually raw device mapping. The idea is if you had something like iSCSI or a storage area network, a SAN, and you're using virtual infrastructure, you've already got a commoditized storage. So, and I'm not talking about attacks for a moment, but you wouldn't need to create a virtual thing because you already had a virtual thing. You just want to point the VM to use the virtual thing instead of having a VMDK, a virtual drive. So what RDM does is it's a fake VMDK. It's a virtual disk. It's real. It points to a real device. So by using that, basically by using another virtual machine with iSCSI, we could actually have the VMDK served up over iSCSI over the network and then point it to a physical device. Now it could bring a desktop to us. And if you ever gone through like password guessing on a host desktop, it's different across the network versus locally. By default, Windows will not lock out administrator locally, only when it's network. Thank you. Thinking a little too much there. Yes, exactly. All right. So that, you know, is that always going to be applicable? Of course not. There's a lot of what if things that could go wrong, but yeah, we're literally thinking outside the box, bringing it to us and thinking we do something with it. It doesn't have to be a pure encapsulation, but you know, it makes sense. If I could boot somebody to a malicious Linux and then SSH to that Linux, I can tamper with their drive, let it reboot back to the normal host, and whatever tampering, assuming it's not encrypted, the whole drive's not encrypted, you know, I might be able to do something there. So kind of an interesting thing. We're in the middle, but we're in the middle of the machine and its hardware. Kind of like a rootkit, but at a lower ring. So we can always solve the problem as a defender or attacker, move it somewhere. What if that top truck in this image it's locked? Okay, well, maybe I can push it on, pull it onto another truck. I mean, the analogy isn't perfect. Most aren't, right? But, you know, if I can't do something, maybe the running out of gas is a better example. I don't know if it's locked. But point being, I can always add a layer to either get some flexibility as a defender or as an attacker, move it somewhere where maybe I can attack it more. I mean, you've seen like in heist movies where they steal the whole safe and then they can work longer on the safe. They've moved the endpoint. And so think about those kinds of opportunities. What about not the network? You know, let's look at some in the middle opportunities for something else. My favorite thing to play with, libraries. So on Linux, we have shared objects, and they're actually easier to tamper with than in Windows, even though DLL hell on Windows gets quite the reputation. We're going to look mostly at Windows here briefly. There are a lot of things you could do here. It's really hard for me not to get off on a tangent and talk about a side loading because if you've ever heard me talk about this topic before, I get off on. It's a pet peeve. People call stuff side loading that isn't side loading. It really makes me mad. So I'm trying really hard not to do that right now, but I will. So if you see the X by X, that is actual side loading, all right? It's a thing that Microsoft added. It really started about Windows 98, but it didn't really come into play until Vista. But the idea was this chaos that we had on Windows where applications were installing, overriding DLLs in System 32. It just had to stop. So we had to override a DLL with a newer DLL that would break your old app because it now wouldn't be the version they were expecting. And so what the side by side is how Windows enables library compatibility as things get installed. And it's one of the reasons you might look at Windows, your used space on your Windows machine and say, how is it 40 gigs? I don't have anything but a bunch of applications I installed and uninstalled. It's because versions of applications, executables, DLLs, fonts even, are loaded in the side-by-side area. And so it's kind of a weird thing to look at because it's kind of like a copy of it as a cache, but it's also historical. So there's a lot of stuff in there. There's also the literal application compatibility toolkit that Microsoft provides. Like if you wanted to make something work on Windows 7, Windows 10, whatever, but it didn't work previous to that version, you could say, if it's installed here, here's a version of the DLL that works. And that's handled a few different ways, but it's this SDB file is the critical thing to look for. It's the components needed when it is a bring your own thing. Of course, third-party applications should, if they're well-behaved, bring their own DLLs and with them and be in their application directory. That's the right way to do those things. But it's such a problem that Microsoft has multiple ways to work around the DLL chaos, which means there's other opportunities for us to get in the middle. But there's other EDR talks going on in the other track today. So that's actually a little bit about what we're talking about here is I could be in the middle of a library call, and that's pretty much what EDRs are doing. They'll do it in a couple of different ways, inline or with some function hooking a different way. But I guess I really can't let it go. DLL side loading, it's just sparkling DLL shenanigans if it's not from S by X, okay? Anytime there's a DLL problem, I see people I highly respect call it side loading, but it's not side loading unless it's in the side-by-side directory. If it's problems the path, looks for a DLL, it's literally in the path. It's not on the side. The side is it skips the path or ignores the path and just goes look in the special directory. So yeah, side loading has to have S by X involved. Anyway, and you can quote me because I rant about that all the time. All right, but you still have the precedence. Anything in the path, the current directory you're running the executable from, the application's installed directory, those are all checked if the DLL doesn't exist anywhere in the path, that DLL will get loaded from. And then you've got other opportunities. A manifest file for .NET and managed code installed on Windows can specify the PE format, can hard code the library where it's getting it from. So there are many exceptions to that. But how can we do this a little more dynamically as an attacker? Or again, maybe you're not supposed to know what's inside the box that you're trying to defend, and you want to add some logging. Well, you could do a couple of things. I have a few tools coming up here. This is one that I just was playing with, that just saw the tweet a few days ago, last week, that does it all for you. Parses a DLL, records all of its exports, all the functions it's providing as official functions you can call, and creates a fake copy of it, or a copy that you can also do something with it. So if you want an all-in-one tool, a single command that gives you a proxy DLL, this tool is the one I would try first. It's in Rust, but it does all the work. There's a couple of other things I mentioned that I've been using, but there are a few commands or expect you to do some work by hand too. This is run one command, and now you have a DLL that's a perfect in the middle DLL for the one you're trying to either hijack maliciously or hijack defensively. The component store, as I was saying, I went a little more in depth here on the application compatibility. The SDB is really cool because it's not just, hey, use this DLL. It's also, hey, pretend the registry also has these settings when you run that application. So maybe you can't edit things in the registry because you don't have local admin, but you can run the application with a compatibility shim that might weaken it. Of course, if you don't have admin, you can't install the compatibility shim. But if it is something you need to look for to see if things are available for you to record, okay? A lot of fun stuff there, as well as the opting out of mitigations can be done in the compatibility shim. So you know what? Let's not do dep or other things. Correct file paths, which is cheating on the file system. Hooking the Windows APIs for visibility. Inline, pretty simple. When the function gets called, it's just the first 5 bytes. If you're talking 32-bit, you have a call address is 1 byte, 4 bytes of an address. Those first 5 bytes are replaced with a jump to a different address. You do whatever you want to, like your shell code, for example, and then you end your functionality with the 5 bytes you've overwritten and then return execution back to where it was. That's inline, something that EDR software has done for a long time. Easy Hook is Microsoft's solution to hook functions. It's something we abuse as attackers, but it's something designed before we started attacking with it. So you have that. There's others. As I was saying, especially when it comes to looking at combining it with AMSI bypass or other signature bypass techniques, there's some of those out there. But basically, if we had to, we can always go back to the Mimi Kittens way. Not Mimi Cats, Mimi Kittens, and just grep through memory looking for regular expressions of things we're interested in for, again, recording that visibility stuff we want to look for. That sharp hook one is pretty neat. Although it's mostly focused on RDP credentials, it's got all the tech in there. If you want to look at the source code in Sharphook, it's got all the tech for hooking arbitrary functions you want to steal secrets from, kind of like a debugger, kind of like inline shell code. So some pretty sweet stuff. So I like Sharphook for that. Import redirection. If I was looking at some custom app and I was like, I need to add logging. People call this function for this. How would I do it? This is the inline I was talking about. Import address table is a concept. This is a construct in memory of a process that keeps track of where its functions are. This isn't something saved to disk. The import address table is where it keeps track of its functions. As it's loaded from a DLL, the import address table is created. Well, I can tamper with that in memory and change where it goes. You want to call a message box? Well, let me just log it. I say malicious code in this picture that I stole from somewhere on the internet, but I could add my logging there, alerts. If I want to do it to the file, I could, but why don't I just add my DLL that does the monitoring to the file if I'm editing the PE file? So it's really not all that creative. I could. And then to come full circle, the export redirection is also possible. We could edit the DLL, and when we're providing the function, when that DLL is providing the function somewhere, we could say, and also go here first, where we can do some logging. And where this is really useful is when you do have a business partner, like say you're I don't know, like a service provider that's providing electronic medical records to hospitals, but you do it for different clients. You could have a different DLL that was either shimmed to do the logging for every client, and everything else is the same. That way, when the actual software gets updated, they're not going to undo your hooking. So it's pretty useful for monitoring. Although, yes, if I were doing this for malicious reasons, I'm already on there. It would require editing the files, so it's really not gaining anything I didn't already have. It's mainly for monitoring for defensive. So I don't know if you found that useful, but I like to think about the opportunities I have, whether I'm coming in pure red or purple, about how I can manipulate those things. One reason is I like to know my tool actually worked if I'm attacking. I like to know that if somebody's killing my tool, if I need to just try harder. So I like to be able to monitor my own tool. Got me thinking about the tactical aspect of this. And then I did come into some contracts where people needed to get out or basically prove that their service level agreements with vendors was not being met. So I had to inject logging into some of these applications. And I realized that, you know what, as we're doing our purple teamy stuff, this would be a great opportunity to add visibility to something we normally wouldn't be able to control. So kind of a fun thing to think about, how we could use that as a philosophical perspective. Yeah, even if we've got stuff encrypted, we move an endpoint where it's not encrypted. So, you know, some opportunities to be creative, I guess. If all that did was kind of stir your imagination, great, I'll call that a win. But hopefully you found at least some of the examples to be a little more practical than the theoretical. Any questions?